Alright, so let's go through checkpoint 12. So we have a slope incline at 30 degrees to the horizontal. Of course, a mass of 4 kg is being pushed at constant speed, meaning there's no change in your kinetic energy by an external force. So there's a constant frictional force of 8 Newton. So of course, I move 6 meters along the slope in 3 seconds. So what is the main power provided by the external force? Okay, so for main power, right, always remember is the work done, which is force multiplied by distance divided by time. So for me, in order to calculate work done, I use the work energy theorem. So remember work energy theorem, so the work done is equal to the gain in kinetic energy plus gain in GPE. Then of course, not to forget, there's a work done against frictional force of 8 Newton. Okay, so for the gain in kinetic energy is 0 because they say constant speed. So what about the gain in GP? Okay, gain in GP, so we know that the mass is 4 kg, so m. So I gain a height of, let's just say, okay, so this one is the opposite, right? So meaning is 6 sine 30, which will give you roughly 3 meters. So just use MGH. So gain in GPE is equal to mgh. So the m is 4, the g is 9.81, the h is roughly 3 meters. So this will actually give you, let's calculate, 0.1, so about 117.7 like that. 2 joules. Okay, so that's the gain in GP. Okay, what about the work done against your frictional force? So we know that the frictional force is 8 Newton, meaning for example, let's just say I have a box here. So there's a frictional force opposing the movement or the motion of the box. So of course, the distance traveled is 6 meters. So meaning that the work done against frictional force is 8 times 6. So this will give you about 48 joules. So this will be the work done against your frictional force. So you just add up. So the total work done by the external force is 117.72 plus your 48. So that will be the total work done. Okay, then since you want the mean power, meaning that you need to divide by a time of 3 seconds. So let's do the calculation. 117.7 plus 48 divided by 3. So you will get a roughly answer of about 55.2 watts.